All right, it is 12:02. We'll go ahead and get started. Good afternoon, everyone, and welcome to DATAMARK Technologies' sixth webinar of the year titled Interoperable Solutions for NG911. I am Stephanie McCowett, DATAMARK's marketing manager, and I'm excited to introduce you to today's presenters. Before we get started, I have a few housekeeping items to make note of. First, all webinar attendees are muted for quality assurance purposes. We wholeheartedly encourage audience participation for this session and all sessions, so feel free to use the chat and Q&A functions of this platform to let us know what you're thinking. Our team will be monitoring the communications that come through and will relay them to the presenters and audience when appropriate during the session. If we can't get to your question before the end of the webinar, we'll follow up with you afterward. So without further ado, I am very excited to introduce you to today's presenters, Jeff Ledbetter, who's a client success manager, and DATAMARK Technologies' new CEO, Mitch Pinkston. Take it away, you two.
Hi, everybody. Thanks for joining. Excited to talk to you today about our company and about interoperability and with GIS and Next Gen 911. Stephanie said, I'm the new CEO of the new DATAMARK Technologies team. I've worked in GIS and public safety my entire professional career. I started at DDTI as a GIS analyst doing data collection and processing. From there, I got into project management and served as the project manager for our first statewide NG911 deployment of core services. Also have some experience leading our operations teams and our research and development teams through the years. Really excited to believe that bringing DATAMARK and DDTI together as DATAMARK Technologies solves a problem that we see in the market today. As you're aware, accurate GIS data plays a critical role in these modern 911 systems. The GIS data the providers need tools to validate, edit, and provision the data into the 911 system, where the core service providers use it to route the call to the correct PSAT and provide accurate location information to the call taker. The problem that we've seen in some cases is the GIS solution providers and the core service providers are not fully integrated, which can lead to issues with data accuracy and completeness. So our vision here of DATAMARK Technologies is a fully integrated GIS solution from the birth of an address all the way through the 911 call. It's a little bit about myself. Jeff, would you like to take an opportunity to introduce yourself now?
Yeah, absolutely. If you're a regular webinar attendee, you definitely know my face. I like to say that I'm webinar famous because I get the opportunity to share lots of important things about GIS data and 911 here on these webinar series. But yeah, I am a client success manager here at DATAMARK, and what I love about that role is that I get to be with clients and make sure that we're empowering them to do all the things that they need to do to be successful with their GIS data in public safety overall. And I'll just echo Mitch's sentiments there. I'm super excited about the coming together of these two companies and the opportunities it'll afford us to do a lot of great things in the world. You know, that's really what drives pretty much probably all of us in this industry, is having an impact on the people that help the people that save lives, right? And eventually the things that we do as GIS nerds filter down to the people that are having their worst day and need the most help. And that's why we're all here. And so I'm excited for what we have to share with you today. Let me just get right into it here. So what we're going to do today is I'm going to set the table a little bit for Mitch. Whoops, got a little click happy there. Sorry about that. I'm going to set the table for Mitch to talk a lot about what he opened up with here by doing a quick review about GIS standards. Again, if you are a regular attendee to our webinar series, you are learning, you know a lot, and you are learning even more about standards with every webinar. We focus on them greatly, but what we have always focused on is how the standards would have you structure your data to be consumed in a next-gen core services environment in theory, right? But what Mitch and the DDTI team bring to DATAMARK Technologies is the actual practice of applying that GIS data structured in a standards-based way, but also all the other crazy combinations that are out there, they've had to deal with over the years, right? And so what I'm excited about the content of this webinar is that Mitch is going to take us through some of the real life and real world impacts and applications of all the things we've been talking about for years over here about how to structure your GIS data. But he's going to talk about why it matters, how it actually gets used in a real life sort of way. So that's what we're going to do today for our webinar. So I'm going to start again with just a brief overview about standards, right? NINA standards. We talk about there's way more than these three, but these three are the ones that for how to structure GIS data for use in next-gen core services are available now. There's even more being developed. I'm on a NINA working group that's going to write an information document called Utilization of GIS Data in Next-Gen Core Services. And you get real specific about what Mitch is about to kind of take us on our journey with. But the data model, the data transition document, which isn't published yet, but that I'm the co-chair of the working group of, and I know it's got a lot of great insights that are coming your way. That document has come through the process and should be approved and published in the next few weeks, maybe a couple of months. But it's under its final ballot now within the working group to be approved, to be submitted for approval and publishing. And there's no reason to anticipate anything except that will be completed very soon, as well as the GIS data stewardship information document. What I love about NINA is not only are they producing the standards that tell you what you must do, but they also produce the information documents that tell you what you perhaps could do or should do, right? The best practices on how to do what the standards require you to do. And all of that drives into a GIS data management workflow, right? Again, not news to you if you're a regular attendee of this webinar series. We talk all the time about GIS data workflow and governance and ownership and some nerdery within that. But just to kind of set the table again for Mitch, we start off with data in multiple formats from multiple business systems, from multiple stakeholders, and we coalesce that through GIS data management and its tools into something that's useful for public safety. Not only useful for next-gen core services, but also for CAD, for indoor mapping systems, for situational awareness, for support of emergency operations centers, department operations centers, et cetera, et cetera. The beauty of GIS, using GIS data in 911 and for next-gen core services is that it forces GIS data providers to create really useful data, not just useful for next-gen core services we're going to talk about in detail today, but for all sorts of applications, public safety and otherwise. And so, as I mentioned several times, Mitch has as well, we're going to focus on how that data that gets structured by these standards and through this workflow process into next-gen core services. And that's really where DDTI's great strength and bench and expertise comes to play with what we at DataMark have been doing for the last few years as well, as far as helping you structure your data. Now we get to really dive into how is it consumed and utilized in a real world setting and move beyond theory into practice. So I'll turn it over to Mitch at this point.
All right, thanks, Jeff. So we'll do kind of the wedding cake approach here. We'll start at a high level and then drill down into some of the sub bullets with individual slides as we go. But as the data comes out of the GIS solutions and comes over into the core services, we see it come in various ways. Unfortunately, they all usually have some level of human interaction. So whether that's SFTP, someone having to set that up and transmit data through there, or through a website, uploading it through a web, or even heard cases of it, being emailed to someone and then copy and pasted. So right off the bat, you've got human interaction. You've got to schedule it or coordinate it and actually take some step there, some manual effort there to get it provisioned into the core services. And then once it comes in, the spatial interface is the first ingress point there in the core. And in the spatial interface, performing quality control checks. So these checks may or may not align with all the checks that have happened prior in the GIS maintenance solution before it came over. And that can be an area of contention where, we're checking for more detailed, more granular things at this point, because in the spatial interface, we have to make sure everything's at a high enough quality that it can be provisioned through into the ECRF for routing calls properly. So right there, we're running quality controls, performing certain data transformations, and ultimately, if everything checked out, publishing data over into the ECRF LBF for use in the 911 system. And then Jeff touched on this as well, but we can publish data from the spatial interface into additional downstream consumers, such as mapping, whether it's a standalone mapping product, something within call handling, CAD, whoever else in the PSAP or elsewhere that may need to use that data that's been created for the 911 system can come out from there as well. And then finally, can provision GIS-based MSAGs. So using the road center lines data and address data to create a traditional MSAG file that we can push through to people that may need to be able to consume that. So this is kind of the first stopping point where we see things where the data is coming from, the data providers using the tools that you all are using, pushing it over into the ESINet, into the core. This is where it first hits us. All right, Jeff, we can go on to the next one, please. Great, so the ECRF LBF, this is where the GIS data lives ultimately within the core. The GIS data itself is used to route calls, and we'll drill. I'm not going to hit these bullets. We'll cover them in additional slides, but that's the primary use case for the GIS data, right? It's to take the location of the caller where the emergency is, which is spatial information, reference it against the spatial information that's in the GIS data, and route the call to the correct PSAT. Prior to doing that, we want to use this data to validate all of this location information ahead of time by the LBF. Of course, the use case there is you want to make sure that before the 911 call happens, you've got valid information both in the ECRF and on the phone record, so that if someone does have to make a call for 911 from that phone number, it's going to be able to route to the correct address and to the correct PSAT. All right, Jeff, we'll go move on to the next one, please. All right, so we're going to drill down a bit here and we'll walk through wireless calls and wireline calls, how it works. Got some real simple diagrams, I hope, that'll be easy to understand and illustrate how this all happens when someone calls for 911. So the first step when an ECRF, so let me start by saying this first line here. The ECRF itself is a database, and there's a server in front of it, and many companies refer to it as a loss server, including us. So we have a loss server standing up in front of the ECRF, and that's the interface to the ECRF. So you'll hear me say ECRF and loss server interchangeably over the next few slides. I just want to clarify, the server is just the server piece, the ECRF is the database piece. So the first step is for the ECRF to determine if it is authoritative for the given location. Of course, many of you are probably familiar with the forest guide and the tree structure of how the ECRFs interoperate and communicate with each other. So the first step is to say, okay, I have this location. Am I the right person to actually answer this call? And it determines this by checking that location against the geodetic coverage that's defined within the ECRF. So that's all pre-provisioned ahead of time to say, yes, I'm the authoritative server for this. I will now go ahead and answer the call. Otherwise, I'll redirect it to whoever is the authoritative server. If it is the authoritative server, then we're going to query the appropriate boundary layer with that geodetic location and do a simple point and polygon intersection function to determine who the correct PSAP is throughout the call to. In the case of two overlapping shapes, the server is configured to use the area of greatest overlap. That's a configuration item. We found that's been the best use case and one that our customers prefer in all of our deployments. And we'll show that here on the next slide with some actual shapes. So if you can jump to the next one, thank you. So when the location information comes in from the carrier, it's typically either going to be in a wireless call, it's either going to be a point or a circle. So in a point, it's very straightforward. It's just a simple point, an XY. And in this use case here, we've got the PSAP, the one on the left, PSAP A, PSAP B on the right. In this case, it says this XY falls within this PSAP. It does the point and polygon lookup. and it returns the URI to actually send that to PSAP A, to send the call to PSAP A. The example on the right, that's a circle, and we see a lot of these in the 911 system as well. So what's happening there, the wireless carriers are giving us an XY with an uncertainty radius and saying, we don't know exactly what their XY is, but we know they're somewhere in this radius, which can be very small, a few meters, all the way out to thousands of meters. And so in that case, the ECRF has to make a decision. How are we going to route the call if we don't have a very good certainty of where the actual caller is? And the majority of the time it falls within one PSAP boundary, and it's a straightforward answer. But in cases where it spans multiple boundaries, we configure it to do an overlap function, determine which PSAP does the majority of the location, does the circle overlap with, and then return that to route the call. So in that case, on the example on the right, the greatest area of overlap is with PSAP A, and the call would route to PSAP A. So that's the kind of simplistic breakdown of how wireless calls route. Again, locations coming in, we're taking that, the ECRF's taking that location, and it's comparing it to the Polygon data that it has within the database, and it's doing a point and Polygon lookup and routing the call appropriately. All right, if you can move on to the next one, please, Jeff. All right, wireline calls. So not as many of these coming into 911 as there once was, of course, but they still, 15, 20% of calls are still coming from wireline addresses. And of course, this is a different sort of function. So the first bullet here is exactly the same as wireless. Its first step is to say, am I the authoritative ECRF to answer this call? So again, if it's not, it bounces it back and does a redirect to who the correct ECRF is for the call. If it is, we move on and now try and query the address data to find a single mapping. So as you're aware of in the standards, we're using addresses, roads, and polygons in the ECRF. The address is going to give us the most granular location. So we're going to first want to check that and see if we can get an actual address point throughout the call. So we'll take the location information coming from the phone record, search the values of the address data, and try and find a match. If we can find a match, we do the point and polygon lookup, send it to that PSAP. Can't find a match, then we go to the roads data. So if there's no address point, we'll fall back to the roads. Hopefully we have a good solid road centerline network that has accurate address ranges on it, and we can route the call to the correct PSAP using the roads. So this is why it's important to have both addresses and roads. Roads are a little more of a safety net, but ideally addresses are going to give us the most granular location. We're going to be able to get it right down to where the building is and all the different sub-address data in certain instances where you have building, floor, room, unit, suite, all that good stuff. And once it finds a point, either an address point or a point along a road center line, it does the same sort of point and polygon intersect to determine who the correct PSAP is throughout the call. So if we bounce over to the next slide, we got an example here. On the left, this is an address point match. So my red bar there is supposed to be a road center line. The dots would be address points. And in this case, let's say on the left there, that is let's say the call is for 100 Main Street. And it has an address point for 100 Main Street. The one that we have highlighted there, it's going to route the call to PSAP A. On the right, though, is an example where, let's say the location of the 911 call is 150 Main Street, and we don't have an address point for 150 Main Street, but we have a break there, and that highlighted section of road has an address range that goes maybe 110 to 180. So it goes and it says, okay, 150 would fall within this range or hit this segment of road. This segment of road falls within the PSAP B polygon. Return the URI for PSAP B and route the call to that PSAP. So again, this is a very simplified way of looking at it, but I found it to be an easy way to kind of digest and try and make sense of exactly what it means when it hits an address, what it means when it hits a road, why it's important to have both pieces of information in there, and why it's important for both of those to be accurate to route a 911 call. All right, let's move on to the next one. I guess we'll hit some of the benefits here. Wireless calls, this sounds very basic, rudimentary, but wireless calls have geodetic location natively. We're getting them with an X and a Y. So of course we should be using spatial data to route the call. Why would we use something tabular or something in a spreadsheet or a database or an ESN number? It's spatial data to begin with. Use accurate spatial data to route the call to the right place. Obviously, this becomes more impactful as caller location improves. I mentioned earlier how phase 1, phase 2, if we get the phase 2 location, we're seeing that we're getting phase 2 location from devices more and more sooner than we have in the past. At one point it was 15, 20 seconds. Now we're seeing a lot of carriers are delivering phase 2 within 7-8 seconds. So this becomes more and more impactful and beneficial as that location improves. Ultimately, be getting phase 2 location coming in with the call. That might be down the road a ways, but we're getting there. And then of course the big check mark here, if you work in public safety, work in a PSAT, or have had to call 911 as a caller, transfers are what we're trying to avoid here ultimately, and more accurate routing results in fewer transfers. So if you've ever had to call 911 and got transferred, it takes an extra 30, 40, 60 seconds. You have to maybe tell the call taker everything you just told the previous call taker. It's an emergency, obviously. You called 911. Transfers are no good for the public or for the call takers and the 911 authorities. So that's really why we're doing this. We want to eliminate or certainly diminish the amount of transfers that happen on 911 calls.
So Mitch, we do have a couple questions that popped up to those. So the first, will wireless calls still use cell tower triangulation and NG, or will it solely use GPS for the geodetic location?
So I just touched on that a little bit. It typically still, so phase 1 location would be the what's coming from the towers, and we're still getting that for the majority of calls. But what we're seeing is a transition to more and more actually getting the phase 2 location, which is the device location, the XY off the device. That information is coming back from the carriers quicker than it has in the past. So that helps us.
All right, awesome. And then we have one hypothetical question from David, which is, if our provisioning routing polygons contain donut holes that represent home ruled PSAP districts, how will your system handle those scenarios where we would not be maintaining routing polygons for those entities?
Okay, so if I'm understanding correctly, we're talking about the provisioning boundary, the authoritative boundary. It's whether it's a donut hole or it's something on the outside of it. What that boundary says is I'm authoritative for answering this call. So obviously, if it falls within that boundary, it goes and does its thing. If it doesn't, what the protocol calls for is responding back to the person who queried, the client, with ideally a redirect to who the appropriate ECRF server is, or at least a message telling it that I'm not authoritative, you need to go ask elsewhere. So in a perfect interoperable world, the ECRF knows who that authoritative server is and can tell the client, here's who you need to go query next with the URI. But in some cases, unfortunately, what you see is not all jurisdictions are doing geospatial routing. So it may not know, there may not be an authoritative loss server for that particular area. Or maybe they're doing things differently, not following the standards. So it can't necessarily redirect and doesn't know who to send it. All right.
Great.
All right. Yeah. So more benefits of geospatial routing. Again, this sounds pretty simple, but leverage the GIS data by the PSAT, provided by the PSAT to determine the routing. So the PSAPs and the GIS data providers in the local jurisdictions know where the calls need to go. The phone, traditionally this stuff comes from the phone companies. But what we're trying to do here with Next Generation is say, no, we have more accurate data now. We have spatial data now. The caller location that's coming in is spatial by nature. So let's use the accurate spatial data that the GIS data providers have at the PSAP level to determine the routing. Also, we'll get into some examples of this in a minute, but the polygons can be set up to account for special cases along borders. state highways, large bodies of water, DoD facilities, really anything you want, you can draw different polygons around to impact the routing and the behavior. And the final bullet, temporary override polygons can be created to account for localized events. And I'll show an example of that here in a second. All right, so border issues. All right, so this is one of our, and this actually goes to one of the questions that we had. So thank you. The example on the left, the call. So what we have highlighted there is if we're doing sector-based phase 1 routing using an ECRF. So that example, we've got a big circle, right? It's a big area of uncertainty based off a tower. So this is a traditional phase 1 location coming into the 911 system. And in this case, it finds that the piece of the pie that we see highlighted there, it says, well, the majority of this falls within PSAP B, right? We talked about our area of greatest overlap rule earlier. So we're going to send the call to PSAP B. But you can see there's a section of that pie slice that falls over the line in the green polygon for PSAP A. And that's our example on the right. So if we have a phase 2 location for the caller coming from the device of the caller, we can actually route the call correctly based on that XY, which in this example would fall in PSAP A. This doesn't happen often, but it happens, and it's important because right there is a transfer. And as we talked about, eliminating transfers or certainly diminishing them is one of the overall goals of using geospatial data to route call. All right, Jeff, next one, Polygon customization. All right, our example on the left, special cases along borders, right? So in this case, you know, the PSAPs know, sometimes there's mutual aid agreements, or for whatever reason, sometimes there's lakes, rivers, bodies of water, different things that you need to draw the polygons around, customize them to reflect who the appropriate agency is to respond to a 911 call. So again, we've got flexibility and we're using spatial data to actually do it. The example on the right is something we've seen in many deployments along water, specifically along the ocean. So if you imagine like PSAP C being out in the Atlantic Ocean or PSAP or Pacific, either of them, a large body of water that maybe you have a Coast Guard or you have a large emergency management PSAP that's going to go out with a marine unit to be able to go out and respond to something out at sea versus maybe a small town that doesn't respond to that. Polygons allow us, again, to spatially go in and customize these things to reflect what the emergency response needs to be. Not necessarily what the town is, who you pay taxes to, or any of that. These are customized for 911 and for the emergency responders. So again, customization, flexibility, and doing it in an accurate way that's spatially oriented. All right, next slide, please. Okay, the one here on the left, temporary override polygons that can be added for localized events. We've done this with marathon events, sporting events, things like that, where you have mobile PSAPs that get fired up for a specific special occasion. And you can actually draw a polygon, have someone on the GIS team draw a polygon, add it into the ECRF, where they say, hey, if someone calls from this stadium or from this specialized localized event, we're going to route the call to the mobile PSAP instead of routing it to PSAP A and then having to do the transfer over to PSAP C. So that's a powerful tool. There's a lot of responsibility that comes with that. You got to make sure that, you know, we're drawing it accurately and everybody's on board with what we're doing there. But that has been something that's been very helpful for a few of our customers. And then on the right, again, in some cases, you have your regular PSAP A and PSAP B, but then you may have state police that respond to the calls along the state highways or the interstates. So how do you handle that? Draw polygons around those areas or around those roads so that in this case, if that's a highway going across where you see the PSAP C polygon and the call comes in from that, then we route the call there. But if it's off the highway in the town, we want to route the call to the local police department. Again, flexibility and spatial orientation is the key here. All right, next, please. So these are just some of the benefits for wireline calls. GIS data provides a more granular representation of the caller location. We've been hammering home on that. And the Civic Location Data Exchange Format, or CLDXF, versus the MSAG, Master Street Address Guide. So again, more granular location. You guys are familiar with this probably from the standards. CLDXF has several more fields, has information spelled out. You can get to a much deeper, more accurate location than you can in an MSAG. And then finally, we talked about border issues, trying to reduce transfers there. Again, these are all things that with spatially oriented data, with things that can be customized by the local GIS providers that know how it should be set up, we can really start to have a positive impact on public safety. All right, civic location data. Okay, so we talked a little bit earlier at the top about how doing validation is an important piece to make sure that we can actually route the call. So do the validation ahead of time to make sure it'll route properly when someone actually calls for help. The GIS data is capable of providing much more detailed location than the MSAG data. And the data conforming to the CLDXF standard, you know, as an example, CLDX standard has 29 fields available for location information attribute. MSAG has 9. Finally, the MSAG can often get you to the correct street, but the GIS, for using accurate address points, can get you to the correct building, floor, unit, room, or seat of a specific address point. So I'm sure all of us in the room can agree that this information, we all believe spatial information matters, especially in a 911 call when you need help the most. And that's what we're saying here is why not use the most accurate stuff to be able to leverage this and facilitate and support the 911 call and the 911 first responders to the best of our ability, and use data to do that. We believe the data matters, and it does. All right. Okay, so some issues that we've seen. Manual steps, touched on that a little bit. Just getting data into the spatial interface at times can have too many manual steps involved there. And then the quality control checks that are run in the spatial interface don't always align with the checks that are run by the GIS data provider. So again, as a GIS data provider, someone that's editing, maintaining the data, you're doing it one way, submit it to the core services. Now that person says, wait a minute, this isn't good enough, you need to try again. Now you're doing the work twice. Maybe you don't understand why it worked one way and didn't work the other because it's not being clear. The two systems aren't integrated. So we've seen this as a problem, and we've heard about it from customers through the years. Civic locations that are LVF invalid are not always reviewed by the GIS data provider to ensure that the data is accurate and complete. So again, if something isn't valid ahead of time, we want to make sure it enters a workflow to get resolved so that if someone ever calls 911, that it's going to be able to route to the right PSAP. And again, having the integration points between the folks using the tools to edit the data and then the core services providers using the actual LVF to validate the records, want to pull those things together and have them more integrated. The GIS data providers do not have the resources or tools to review those records in a timely manner. As we're aware, GIS data is used by multiple agencies on the local and state level. That's one of the great things about GIS data. It can serve so many great purposes. But being pulled into, and I use the word pulled because oftentimes we see folks are pulled into NextGen 911. And now it's another thing they have to maintain. And maybe they don't have the time to do it or have the tools to be able to do it in a timely manner. And then finally, incomplete and inaccurate GIS can delay the transition from a traditional MSAG to a GIS-based MSAG. This is another thing that we've seen and heard from many customers through the years. Yeah, you're using an MSAG and it's old and dated and inaccurate, and it's got years and years of bad information in there. We've invested in our GIS team. We want to use the GIS to generate an MSAG so that when something needs fixed, you just fix it once in the GIS by the GIS data provider. But to get to that point, the GIS data has to be at a certain level of accuracy and completeness. So if we can have a fully integrated GIS solution, we can help move people off those old MSAGs and into one that's being generated from the accurate GIS data. All right, next, please. All right, so best practices. These are the counters to the problems that we just talked about. We want to see GIS data provisioned to the spatial interface in a seamless way with no manual steps involved. As soon as you commit that edit, we want to see it run through its checks and be provisioned into the 911 system as quickly as possible. We want to make sure those quality control checks that are performed by the spatial interface align with what is being done by the GIS data provider. Again, shouldn't be siloed, throwing it over the wall, getting mixed results back from different people. We want to see it aligned and flow through so that the fix can go through as quickly as possible and have the impact, the desired impact that it needs. And then finally, the LBF discrepancies that are sent back to the GIS data provider to review along the GIS data in the maintenance solution. So if we have discrepancies, things that are wrong with the GIS data or the phone record, we want the GIS data providers to be able to review that spatially on the map, because again, it's spatial data, and they're going to know best where the fix is and how to make the fix. So these are the best practices. These are the things that, as a new team here at DATAMARK Technologies, we're committed to pulling these integrations together so that we can, again, have a fully integrated solution from the beginning, birth of an address, all the way through the 911 call, a way to efficiently get fixes pushed through, and a way to review errors as they happen and maintain the data for the life of the system. All right, next. I think that's the last of our slides. How are we on time? 2:38. Great. So we've got plenty of time for questions. I don't know if there's any in the chat or anybody has anybody they want to ask.
All right, so we do have a few questions that have come in through the Q&A. So we can go through there, and then if anybody has any other questions, now is the time to submit them. We'll kind of go through those the rest of our time here. So we do have one question. Is there any way to get indoor mapping to overlap a better Z-axis triangulation?
Yeah, is that something you can speak to, Jeff?
Yeah, I can take a crack at that for sure. Couple things there, right? One is a better Z-axis triangulation. I cannot speak to that. Right, there's a lot of things that go into a black box that come out with that. But you know, Z-axis is an interesting topic because it's just like with wireless phase 2, there's going to be this, we're currently in and needing to enrich our resources for an education process to understand what you were talking about with phase 2, Mitch, that there's a location, but then there's also a confidence rating and a distance of uncertainty. And those Z-axis information is coming to your call handling equipment with those same factors on Z, right? So how can we overlay that, whatever comes into the call handling equipment, onto indoor maps? That is a really good question, and it's an important opportunity for your indoor mapping provider to have an integration to your call handling equipment, to your CAD systems, to other 911 mapping applications like the ones that our partners at Rapid Deploy have out there, that can integrate that GIS data. And there's an important note as well. As you're creating your indoor mapping plans, they should be created in a GIS format, right? So that you get all the benefits of GIS data, the high resolution, the data behind the data, the attributes, if you will, about the indoor spaces, all come in a data format that are useful and interactive, as opposed to things like PDF maps and things like that. So there's a lot of different ways to integrate it into a lot of different applications, and the ones that will bring in your Z-axis data with uncertainty and confidence factors. It's a complicated question, but those are some things you need to start thinking about. How do I acquire the indoor mapping data? How do I integrate that into the particular applications that I need to integrate it to? And do those applications then bring in the Z-axis value? And how do I even interpret that location, uncertainty, and confidence factor information that comes in from that Z-axis?
All right, awesome. And then one question from Tony: how do you handle apartments? My data has the main apartment address, but not all the individual building units.
Yeah, so the ideal state there would be, and this is why the standards have the additional unit information or fields to put the additional unit information in, is to have that populated so that you can know that it's 100 Main Street, floor 2, unit 206 or whatever it is. From the ECRF perspective, when the 911 call happens, if the GIS data has that level of information, there's an address point that matches those values, it's going to pick that address point, do the point in Polygon lookup, and route the call appropriately. If it doesn't have all those levels of detail, it can still find an address point for 200 Main without the building floor unit stuff and route the call appropriately to that. Problem with that is there may be multiple 200 Main, if you just have one point for the building of 200 Main Street versus having 400 apartment units spread across, a large city block or something, that could then potentially route the call to a different PSAP if it's a large enough area that it spans, but certainly complicate the dispatch that the call taker is actually going to be performing. So if they don't know, if they just know that it's 200 Main Street, they're going to be limited in the information that they can give the first responders to be able to get there as quickly and efficiently as possible.
All right. And from an anonymous attendee, can a wireless location be determined on a device using SOS capabilities, IoT, VoIP, in address or in areas that do not have cellular towers or sectors, or how does that work?
I do not know. Jeff, do you know?
Yeah, that's definitely outside of my GIS nerd wheelhouse. Sorry.
Yeah, sorry about that. Good question. Let's see if we can find an answer.
All right, and while you're looking that up, another anonymous attendee is wondering, will we be in attendance at the Esri UC 2024 in San Diego, California?
This one hurts my heart that I don't get to go, but I think we'll probably have some of our Southern California staff be down there. Usually there's a Michael Baker International booth, and I'm sure we'll be hanging around that. So if you have questions about some of these things and are around there and want to ping some of us, look for this DATAMARK Technologies logo that's on the virtual wall behind me here, and hit them up.
All right, and then our final, we have a couple more, sorry. So how do you recommend PSAP boundary changes be documented prior to implementation to the ECRF and LVF?
How they be documented? Could you just say that again, please, Steph?
Yeah,
How do you recommend PSAP boundary changes be documented prior to implementation to the ECRF and LVF?
I think this may be a question about when is a change warranted, right? When isn't a change authoritative? Would it require an annexation order or something like that to implement the change? Or would it be more like whenever the call answering and response pattern of the agency changes, we should update those boundaries? That's my thought on the question, if I'm interpreting it correctly, is, whenever there's these boundaries don't reflect legal or administrative boundaries, right? They reflect boundaries that answer the question, where do I send this call? And when the particular agency that would get the call for a particular location changes, that boundary should be reflected of that change.
Yep.
All right, and then oh no, we have a few more. Okay. What are the sources of authoritative address data from Julia?
I'll take a crack at that one too. You saw on the slide when I set the table, talked about multiple input sources from multiple business systems with multiple stakeholders. So the source of authoritative data varies from place to place, but typically there is some statute, some regulation, some authority given somewhere. I worked at Greater Harris County 911 for a number of years in Houston, Texas area. And we had, across the two counties that we served, we had different authorities from different places. In fact, the statutory default authority in Texas is the power company that provides service, because basically every dwelling, at least at the time I worked there, every building, every structure is probably going to have power. Most are, at least, and so you're going to need an address from them. But there were some cities, namely the city of Houston, asserted their authority over that, created an ordinance and had that authoritative data or authority to create the data. That doesn't mean that the people that assign the addresses also provide the GIS data. So it really varies from place to place, but typically whoever assigns the data is responsible for the data that gets put out there, but it may be their GIS department, it may be a planning department, it may be the power company, it may be a water company, somebody like that services each of those structures.
All right, and then I think this is our final question, but reminder to anybody who might have one, let's submit those as soon as we can. Oh, we have another one that popped up. Okay, so will DATAMARK Technologies continue to work with the state of Ohio on LBRS and NG911 statewide project? From Jason.
Yes, absolutely. Yep, we're fully committed to our existing commitment to the state of Ohio on LBRS and next gen. Yep.
All right, awesome. And then our address data manages apartments by using the main address. Okay, no, I think this is just someone answering that previous authoritative data question. All right. Well, that's the end of our questions. Mitch and Jeff, did you have any parting words before we sign off?
No, thank you everybody for your time today to listen and hear a little bit about our new team and plans going forward, and hopefully you got a little more insight into how things work within the core services. All this work we're doing up front on the GIS data, it really matters. It really matters within the 911 system. So keep doing all the right things, and hopefully you found this helpful, and thank you for your time.
Yeah, and I'll just, I put up our contact information there. I'll just say that if anybody has any other questions or wants to get into more details about anything we talked about, feel free to reach out to us. As the slide before said as well, we'll be at the NENA conference next week, or I guess this weekend, really, mostly. But we'll be there in force, and we'll look forward to talking to anybody who wants to talk about our favorite GIS nerdy topics. So come see us, and we'll look forward to chatting with you there.
All right, awesome. Thanks, everyone. Look out in your emails, because we always send the recordings of the webinar to every registrant after the fact. So you'll see those in your inbox probably Thursday or Friday of this week. And we will see you at NENA this weekend. Thanks.
Bye, everybody.
Thanks.